Hey there everyone, welcome to another interesting video on pyMechanical where we will be focusing on how to connect your Python interface or your IDE to a pyMechanical instance and run on the logic. So we will begin from importing a geometry, creating connections, mesh it, add name selection, add supports, loads and solve it, and we will save it as well. So first thing that you need, I'm using VS Code, and right now I have a virtual environment named as Ansys. I have already installed all the libraries required. So what you need to do is you just have to install your libraries using pip install, which is Ansys Mechanical Core, and all the libraries are available in Ansys GitHub repository, which is under Ansys pyMechanical. And then next we will try to import all the libraries. So our entry point is Ansys Mechanical Core. From there we will import Launch Mechanical, which is used to start mechanical locally, and then the app, which is the app itself, and then Find Mechanical. If you already have several versions in your system, you can use Find Mechanical to find that version, and couple of global variables, and I will show the usage of it. Next thing, most important thing, is how does this Python interface or this notebook connect to mechanical instance. It uses the grpc interface, and that requires you to have Ansys version greater than 2023. So this is the one which I have noted from their repo, which says it should be 231, which is 2023 R1, or 2023 R2, or 2024 R1, or by this time when I upload the video, 2024 R2 will also be included. Now there are two ways you can launch mechanical. One is using batch mode, and another one is through the UI version. So I will show you both of them, and then we can also see we can also make use of start instance parameter, which says if there is already an instance running in your system, throw some IP address and port, you can also use it. And then log level. So these are the things which I have already noted below. Log level, like if you want to give a warning in the console or the output of this cell or error or info. And then we have this log mechanical. So any script that you send to mechanical can be stored in a text file. I will also show you that. And then we have this verbose mechanical, which says whenever it launches mechanical uh, or closes it, whether you want the output of those or not. So first thing is this one mechanical, which is the app itself, and the function for it is launch mechanical. Here if you just hover your mouse here, you will see all the parameters what it does. So I have picked up some couple of most important ones. I will go through it. Exec file default is none, but you can also mm, pass the exe file which actually runs the Ansys. For example, this is the one. Let me just run it. So here it says find mechanical version is 2023 R20. If I run it, you will see that okay, I have this available. If I press 2023 R1 and pass it, it will say, see, it gave an error because it does not exist. I have 2023 R2, so that's the reason it is giving me this path. So you can just directly copy this path and paste it in the exe file. Coming to batch, default is true. That means mechanical will be launched in batch mode. You will not see the interface, but if you make it false, you can see the mechanical running side by side. Now coming to start instance, whether you want a new instance to be started or which is already running, but for that you need an IP address and the port. So for that local instance. Now coming to log level, I want all the uh, all the information here. For example, if I just hover here and if I to log, it says level of message to print to the console. Options are warning, print only warning messages, or error to, I mean, it will print only the error messages, or info, it will print all messages. So I have added info here. Coming to log mechanical, it will, so whatever scripts or the Python code you're passing to mechanical, that will be stored in this file. So this is a file which is a relative path. You can pass the full path as well. And then verbose mechanical, which says whether you want all the output from the mechanical instance or not. So let me run this, and you will notice that it will just launch my, this is the grpc service which I was talking about, and these are all the log information, and this is running this Ansys version because this is the only one I have. And then all this uh, so let's wait for some time so that it launches mechanical. and it says waiting for mechanical to be ready, and here we go. So I have this empty instance of mechanical. You will see there is no geometry, no name selection, no analysis added. So what I will do is I will just put it side by side, so that we all can see what is happening. I think this much will be sufficient to visualize, right? Okay, so I have this mechanical is open. So you see mechanical enterprise product version 2023 R2 and build it. And if you want to exit it, you can just call mechanical.exit, but force true is optional. What it says is, let's say I don't pass anything, I will just call mechanical.exit method. So it will just close it, but in case you have any unsaved thing, it will give a pop-up telling that do you want to save or not. So it will close from the interface, but it will not close the instance. So for that reason, if you pass force, it will force exit the mechanical. For time being, I will not use it. Now this we have already seen. If you want to find any mechanical instance available or not, you can just call this. Coming to this mechanical, now the mechanical is already open. Now how to get what is the current working directory of this Ansys. So one thing is, you can run a Python script. For example, if I go to uh, automation and scripting, if I pass ext api data model dot project directory, I will get the project directory here. So there are two ways: either run through a project Python script, or you can just call mechanical dot project directory. Both will give me the same output. So you will see all my files are here. So both are giving the same output. I have in temp folder because I have not yet saved. Now you can also upload your files to this folder. For that, you have to call mechanical.upload. You can pass the file name and where do you want to upload, so which is project directory. This is also good way. For example, if you want to load some geometry files here and then call it, you can do that. And then the same thing, so here it will say my list is empty because there are no other files, I mean no extra files. If you would have uploaded anything, then it will show here. Now let's start with geometry import. So I have this geometry which is in my uh, local folder, which is called a geom.scdoc, which is basically file. And if I print it, this is the file path. Now to run any script, you have to pass that script. So to pass that script, you should have a script first. So I have already written this script, which is to import a geometry. So all these things, I already have a playlist automating the boring stuff in Ansys Mechanical. I will leave the link in the description. You can open and everything has been covered. So here what I am doing is, first I am creating a geometry group. For that, you just right click and call this add geometry import, right? And then you call a file. Now when you do that, you have couple of options to import. For example, whether you want to process solids or surfaces or lines. So for me, this geometry is a 3D model, so I will have true for all, and surface and lines are false. And I will store it in a preference which is under mechanical utilities, geometry import preference. And then do you want to import name selections or not, whether to process name selection or not, whether to have like space claim body can also have the inbuilt materials, right? Name selections as well. Even it can be any other format. So for that, you see I have added automatic. You can have a SolidWorks model as well. And then whether to process material properties within the model or not. Mixed import resolution, for example, you will have multiple dimension, multiple unit models, that also you can pass it. Once you pass it, you will call geometry import group, which is that group, and then import with the geometry part, format, and the preference. So right now what I have done is, I have added this entire script. This is a Python script which you would have run within the mechanical, and I have stored in a variable called as script geometry import. Now I will run this. So for that, what you need to do is, you have to call mechanical dot run Python script. This is the method, and you have to pass that script. So script is a string, and you should also remember that if you run the script, it returns a string. Okay, so for example, within this, if you have any variable, you can also print it. So that's why I have written here mechanical dot run Python script returns only string, and it corresponds to the last output. If it is a list output, you have to convert it into a string. So if I run this, and you can also log these messages. So logging right now is not required. Okay, or maybe I can just so that I can see show you the log at the end. So once I run it, you will see it first created a geometry group, and then it will add all these preferences, and then it will generate the 3D model. And you will by the time it loads, I will also show you. So I have this geometry import, right? So I know the type of it, and if I convert it into a string, you have to call this toString. And if I print it, if I want the outcome of it, I will just call it, and then it will give me the output. So let's wait for this geometry import to be completed. So finally it is completed. It took almost 44 seconds, and I already have this geometry import, right? So if I go to automation and call scripting, and if I just call this geometry import, you will see it's not showing, but that's fine. But my mechanical instance already knows it. So if I run it, so you see it has returned this. So whatever variable you have it within the script, you can call it back using this. You have to convert into a string, but this is an object type, right? So you have to convert it to a string, and you can get the return of it. Now I will create connections. For that, I am creating a connection group, and then create automatic connection. For the time being, I will just have bonded contacts. Okay, I will run it. This is a script in a string, and then I will pass the string. So once you see this script, it will create this connection. Okay, automatic connection. Now I have to generate a mesh. So this is model.mesh, and I will create the or default mesh. I don't want to give any sizing for now. And if I run this, you will notice that this model has been meshed. Now I will create a name selection. So what I want is, I want the top surface where I want to apply a force as name selection face force, and at the bottom where I want uh, the fixed support, I will call it as ns face fixed support. So for this, you have to put a logic. For example, I want to get a surface whose area is so and so, whose diameter radius is so and so. So all this you have to pass in the logic, but right now, just for the sake of this video, I have this selection info id stored because I know the id of this subject. So this selection info, how to get selection manager, how to get create this, all these are covered under my playlist automating the boring stuff in Ansys Mechanical. You can go and watch over the video. Each videos are organized. So I will just run this add this script in this variable. You might have this under a separate file as well. You can just read that file, but now I have added. And then once I pass the script, you will notice that I created this face, which is my face force, and then this face, which is my fixed support. So this is done. Now I will add a static structural analysis. So I have this add static structural. I will add the fixed support, use the same name selection. I will add a force, and I will use the force face name selection, and I will also assign values for the force. So I have one time step uh, analysis, and I will add 100 Newton. Okay. Once I run this script and then pass the script, so you will see that my analysis, I have a fixed support. Let me show you this. So I have this fixed support and also the force applied, right? I have this force of 100 Newton and fixed support at the base. Now what I need to do is I have to solve it. So it is analysis.solve. I will just run this script, and you will notice that uh, my analysis has been completed. Let's add some result. So I have this total deformation, and I will add deformation only for this face. I will save this script and then pass the script. You will see that my total deformation for this face has been generated. Now I have to save it. So right now you can save it in this is my path where I'm currently working. And since you're running on a mechanical, so you can save only in mecdb file. So if you go to file, if you click on save, you will notice that you can only see this formats, right? mecdb file or mec.file. So this one is there. And there is one more method called as force unlocks. For example, you already have this saved, and if you try to run it again, it will throw an error. So for that, you can unlock it and then save it. So right now I don't have any file here. I'll just click on save. You will see this unsaved has sorry, I have not yet passed the string. So here on the top you see unsaved, and once I click on this, it gave me an error. Maybe this path, right? Maybe it's not taking. Okay, it's saved. So because of this escape character, it was not working. So I have this pyMechanical db saved. Now we can exit it. So if I click on exit, force true is not required because I have already saved it, but it's fine. So if I click, then it shows shutdown as finished. Now how do I open the same file? So what I can do, I can again open this mechanical new instance. So let me just show it for you. I have opened this mechanical and I will go at the bottom. So I have this, right? So I can just pass mechanical.run script, and then I will open the file which I just saved, right? So I have this empty. Let's see if it works or not. I have this and then I will execute it. So I think it's same double escape characters. Yeah, it worked. So you see this entire analysis that we completed has been imported. Again, you can work on it. Now let me just exit it. Okay, once I do that, so this was all about remote session. Now there is one more thing called as embedded session. For example, this right now I'm in this VS Code, right? This VS Code itself will act as mechanical, so it will not open a mechanical instance. Instead you can work on this window directly with the ext API entry point. You don't have to pass the Python script to mechanical. So for that, right now I have in this version, and then I will add the app to my existing Python variable. So as I said, you can use this your this notebook, Python Jupyter notebook, and then you can use Ansys here itself. So let's run it. So I already have a pythonnet package, so it's telling that uninstall it and use the Ansys pythonnet. So if you want, you can do it, but it's not an issue. Now you will see that you can open the existing file directly from this app. So my app, whatever you see, is this window itself is my mechanical. To show you that, so you will notice that if I just call ext API directly, it is telling that okay, this is a part of this, and you can just call model as well. ext API, no. So I think it's project dot model because I used to use directly model project dot model. You will notice that I got the model object. So everything, I'm not even passing the string to any mechanical instance or anything. I'm just running it directly. You see, it is showing everything. Even you can directly call model like we used to do in our videos. You will see both are giving the same. And then you can save the app. Project is never saved. File path is required for first time. So let's do that. Instead of this, let me pass this. Maybe it will give an error if it is the same. No, it did not give because I think path is save is required. Path is required, and then I will exit. So this was all about pyMechanical. I hope you enjoyed it. To learn all these properties, you can watch my playlist, and then see you soon in next video.